Okay, so I'm going to show you how to use cusinaire rods to solve a mixed number subtraction question. So our number is 5 1/3 and we are subtracting 3 1/2 from that. So the first thing that we need to do is we need to show our two numbers, 5 1/3 and 3 1/2, in cusinaire rods. So since each of these fractions have parts or laid out in parts of a whole, 5 1/3 means that each whole is separated into 3 parts. So that means that each of our denominator is going to be 1, 2, 3 on each of those. So our number here is 3 over 3. That gives us 1 whole. Since we have 5 1/3, we are going to need 5 wholes and then 1/3. So we've got 1 whole, we've got 2 wholes, we've got 3 wholes, we've got 4 wholes, and we have 5 wholes. And then 1/3, our denominator is 3 and our numerator is 1. So that's what that looks like in cusinaire rods. Our next question, subtract 3 1/2. So when we talk about 3 1/2, it means that each of those wholes is divided into halves, is cut up into halves. So that means that our denominator is 2. So if we're going to have a whole that's divided into 2, that means we're going to have a numerator that's 2 and a denominator that's 2. This is 1 whole. 2 over 2 is 1 whole. We need 3 of those. So I've got 1, 2, 3 wholes, and 1/2 tells me my denominator is 2 and my numerator is 1. Okay, so I've got 1, 2, 3 wholes and a half. Okay, so here's my question. And the next thing I need to do is realize that each of these wholes is the same value as each of these wholes. So if I'm subtracting 3 1/2 from 5 1/3, it just means that I'm going to take away 1/2 or 1 whole for each of these wholes. So there's 1, there's 2, and there's 3. Okay, so now I'm left over. I'll bring these down here. 1 whole, 2 wholes, and a third. Subtract, because we still need to subtract that 1/2. Well, 1/2 we know is more than 1/3, and for the interest of working with friendly numbers, I will subtract 1/2 from a whole, because I know that 1 whole subtract a whole. 1 whole subtract a half is just simply a half. So this means that I can get rid of my subtraction now. I have switched this whole out for a half because a half and a half is a whole. Okay? So now this means that I have 1 whole plus a half plus a third. That's my answer. Now I could write it that way. That would be a decomposed number, or a decomposed mixed number, or a decomposed improper fraction. But if I want to write this as a mixed number or as an improper fraction, then I still need to figure out what I have here. So in order to do that, I need to have a common denominator here. So I know that 3 and 2 is not the same denominator. So I need to figure out what their common denominator is. And to do that, I'm just going to write the multiples of each of that number. So with 3, I would say 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. Okay? For 2, and I can write this in a T-chart here, these are my multiples of 3, these are my multiples of 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Okay, so here we go. I have my lowest common multiple right there. So it just means that I now need to take these denominators, or these fractions, and put them in, create an equivalent fraction out of 6, okay? So I need to take these, and I need to do something to them. So what I'm going to do is I'm going to turn this into a fraction out of 6, which means that since the denominator, I need to multiply that by 2. This fraction here, I need to multiply by 3. This fraction here, I need to multiply by 2. Okay? So now what I'm going to do is I'm going to say, well, if I'm multiplying by 2, it just means that I have 2 groups. So this is multiplying by 2. Whenever I'm multiplying, it means I'm adding in groups of 2. So that gives me a denominator of 6. Put these together. Oops. So my new fraction here is 2 over 6. I'm going to multiply this by 3, which just means I'm going to have 1, 2, 3 groups of that fraction. So here we go, 1, 2, and 3. I'm just going to move these down here so we can see them nice and plain.
Are there any highlighters sitting around that are not being used?
So here we go. I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this one here, since it is thirds, all that I would do, 3/3 is 1 whole. It still is equal or equivalent to 1 whole. It's just that we have 1 whole that is divided into 6 parts. So 6 equal parts. Okay, I'm going to try to put these. I'm not going to worry about that. Okay. So what is my answer? Well, now that they're all equivalent, oops, if I could put it this way. Now that we have fractions that have the same denominator, we can just add across the top. So we've got 1 whole, and we can take our numerators and add them. I've got 1, 2, 3, 4, 5. 5 over 6. So I've got 1 whole and 5 over 6. If I wanted to express this as an improper fraction, so I've got this is equal to 1 whole and 5 over 6. If I want to express that as an improper fraction, I just need to see how many total parts of a whole I have. Each of my wholes is going to be in 6 parts. How many parts do I have? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So that's 3 ways to get the same answer.